Hi everyone, hope you're okay. So we're going to do 599 and 600 in a similar way to the last video using Google Chrome and PowerPoint. So clip 599 to start with. So 599 is about the angle that's formed between a tangent and a radius. So the first bit to look at is, let's have a go at having a tangent and a radius. So remember, a tangent is a line which just touches a circle at one point, and the radius is a line that goes from the center to the circumference. So if I move this blue dot round, so that's where the tangent and radius meet, you'll notice what happens no matter what size the circle is or where the line is. You can have a bit of fun with it, spin it round. It's always going to be 90 degrees wherever it is. So the key word you're looking for in a question, if it's involving this circle theory, is you've got a tangent. Okay, let's have a go at questions. The first two on this will be really easy because you're just identifying, can you remember that it's going to be 90 degrees? So question one, diagram shows a circle, A lies the circumference, A and B lie on a tangent to the circle. So A and B are on a tangent, which means that OA and the line are at 90 degrees. So what's OAB? That's straightforward, 90 degrees. So question two is exactly the same. Question three becomes a little bit trickier. So let's have a go at that one. So it shows a circle. A lies on the circumference of the circle. A and B lie on a tangent. So you know that's a tangent. You know if it's got a center there, O, the OA is the radius. Given that OBA equals 39 degrees. So let's get the pen. OBA is 39 degrees, which means that this angle in here is 39. I've got to work out what AOB is, so I've got to work out this one. Well, using the circle theory rule that this one's about, which is the angle between a tangent and radius is 90 degrees. This one is 90. Well, again, another really straightforward question. Once you know that that's 90 degrees, 90 plus 39 is 129 degrees. That's the total. And if I then do angles in the triangle, add up to 180, take away 129 degrees, I would get 51 degrees. So AOB, the angle at the top of this triangle, is 51 degrees. So let's go to question 5. So this looks a little bit trickier. Okay, let's try purple this time. So given that TAB is 41, so TAB, this angle inside here is 41 degrees. Okay, do I know anything else? Well, I know this is a tangent, and then this line here is the radius. So I know that that's 90 degrees, and then I also know that this bit here is 90 degrees as well. So if I do that bit in green, so that whole angle there is 90 degrees. So if I do 90, take away 41, that would be, take 40 off is 50, take 1 off is 49. So that means this angle inside the triangle at the bottom is 49. Now I've got two more angles here, and I've also got OA and OB. Now you've got to know, as one of the rules, that if you have two lines that are the same, that's a radius of a circle, that's also a radius of a circle. Definition is the line between the center and the outside or the circumference, that's a radius. So these two are equal in length. So what type of triangle does it create? Well, it creates an isosceles triangle. Which means that the base angles in an isosceles triangle are the same. So this one here would be 49 degrees. And then I need to find AOB. So I've got to find out this angle. So to do that, what we're going to do? Well, 49 add 49 is 98. And then in angles in a triangle are add up to 180 degrees. I take away 98 from that. So if I take away 100, that would be 80. Add 2 on, so that's 82 degrees. So AOB will be 82. So notice you've got your rule using the tangent and radius is 90 degrees, but you've also got to use a different rule, another rule, involving isosceles triangles. Whenever you see a triangle that looks like that, we've got a chord, which is this line from A to B, and 2 radiuses or 2 radii, that always creates an isosceles. Right, let's have a go at question 9. Should do question 8. Let's go to question 9. Okay, so next. Right, so same thing again. So we've got A and B on circumference. We've got A and T that are tangent, so that's a tangent. And then this line is, let's draw on. This line is the radius, and this line is the tangent. So that means that angle in there is 90 degrees. Okay, what else does it give us? Well, it says that ABO, that one in there is 31 degrees. Okay, so based on what I've just said in the last question, that line and that line, they're both radii, and actually this up to that point there is also radius, not that whole line, so just be careful. So those 2 lines are the same, equal in length, which means that this angle in here, this little one, is also 31 degrees because it makes an isosceles triangle, which means that, let's go to green at the top, this green one here, I can work out because it's inside a triangle. If you ever get stuck, do a quick sketch of the triangle so you know what you've got. That's 31, that's 31, and I'm trying to find that one. Well, 180, take away, add them 2 together, you get 62. So that means I've got 118 left. So that means the angle at the top is 118 degrees. Now, next, this one is angles on a straight line because it tells you TOB is a straight line. TOB is a straight line. So this angle here is 180, take away the green angle there, which was 118. That's 62. So this angle in here is 62. Now, this one's 90 because we worked that out. That's the first one we put in. This one's 62. So if I then do 90 plus 62, the pen's going dodgy. 90 plus 62 is 152. So those 2 add up to 152, and then I've got to add something on to make 180 degrees, and that would be OTA. So OTA is equal to 180 take away 152, which is 28 degrees. So what's the question asked me to find? To work out ATO. ATO, well, that's the same thing. OTA and ATO are the same thing. So the answer is 28 degrees. Okay, that's quite a tricky question with the amount of information that you've got to know and apply. Think about it. It's isosceles triangles, angles in a straight line. So it's all the easier rules on angles that you've already done. Right, let's jump to question 12. So this is the last one. So A and B line and circumference of a circle. Lost it. Okay. So A and C line and circumference of a circle. A and B line a tangent. So A and B is a tangent. O and A is the radius. So that means this is 90 degrees. So it's a 90 degree right angle triangle. Given that OA is 12, so O to A is 12. So this is 12 centimeters and A to B is 16. Work out the length of CB. So I've got to work out this little bit here. Right. So if you're struggling, I guess do a quick sketch. That didn't quite work. That's 90 degrees, that's 16, that's 12. And I've got to find that little bit here. Well, do I know what this is, O to C? Well, it's the same as this because it's just the radius of the circle. So that bit's 12 degrees, sorry, 12 centimeters. Right, the rest of it's nothing to do with angles, just the fact that you've got this 90 degrees here. Right, so how am I going to find the length O to B? Because that's what I need to find. If I take 12 away, I get that CB. So what do you know? You've got two sides and a right angle triangle to find the hypotenuse of a right angle triangle. Well, you should remember that's Pythagoras. So if I do 16 squared plus 12 squared, remember square, square, add, and then square root my answer. So let's do 16 squared is 256 plus 12 squared is 144. That should be 400, shouldn't it? So I'm looking for the square root of 400. Well, that is 20. So that means O to B is 20 centimeters. So if O to B is 20 centimeters and O to C is 12, I just do 20, take away 12, and I get 8 centimeters. So answer C to B is 8 centimeters. So there's applying circle theory and Pythagoras into one question. Question that looks fairly straightforward, but if you don't recognize the topics within one, so two different topics within one question, it becomes quite tricky. Right, now your turn to have a go at the questions that are on Hegarty Maths.